Yeah, okay, so here we are dealing with complex equations. So now remember that I is sometimes used instead of J. Okay, so here, let's have a look at the first one we have here. Okay, so now what we can do first is we can simplify I to the power 5. Okay, so from our powers of I or J, let's say if you have I to the power 5 here, this is an odd power. So what do we do? Split it. So this will be I to the power 4 times I. So now I to the power 4, that's an even power. So we use our exponent law, that will be I squared all squared. You're clear with that? Times I, and then we know what is I squared. I squared or J squared is minus 1, so that's minus 1 squared times I. Okay, what we can do is instead of keep on copying this down over and over again here, we can show working for I to the power 5 on the side. You follow? So, minus 1 squared, that will be just 1 times I. And you can see now, writing the 1 in I, it's better to use J instead of I now. Alright? We can easily make a mistake here and think that this is an 11. You know, when we're going from step to step. So now the 1 times I is I, so let's just replace that. So therefore you have x plus yi is equal to 5 plus I divided by 1 minus I. So now from here, what do we do? Two options now. Okay. This is division in rectangular form. So we can multiply, we can simplify or rationalize the denominator by multiplying by the conjugate of the denominator. Or the other option is getting rid of this denominator of the fraction, cross multiplying. Okay, let's just deal with both ways. Which way did you try? Cross multiplying. Okay, let's do the cross multiplying first, and then we will do the other technique, and you will see the other way works out even better, shorter. So if I cross multiply it, so that will be x plus yi multiplied by 1 minus I is equal to 5 plus I. So now I will have to remove the brackets here. Alright, so that will be x times 1, which is x. X times minus I will be minus xi. And then you got yi times 1, which is just y times I. And then you got yi times minus I. That will be a negative yi squared. You're clear with that? This is equal to 5 plus I. Alright. So now, whenever we have a power that's higher than 1, we simplify it. So it's clear here, you got I squared again. So now this will be x minus xi plus yi minus y times I squared here is minus 1, and this is equal to 5 plus I. Okay. So now we got x minus xi plus yi. Negative times negative here, that's a positive. Y is equal to 5 plus I. So now, our right hand side has been simplified. Well, basically there's nothing more to do here. The left hand side now, we've got a problem here. There's two i's there, can you see that? You need to simplify. So what are we working towards? We are working towards a complex number on the left hand side, a single complex number on the left hand side. So it's going to be a plus b times I on the left, and on the right hand side, c plus d times I. So then we will equate real on the left hand side equal to real on the right hand side. So now, the only part to simplify is this one here. Right, so what's real on the left hand side? Anything that does not have I or j multiplied by it. So real on the left hand side is x plus this y. Can you see that? So that will be x plus y. Now here, there's two i's there. What can I do here? I can take out a common factor. So that will be plus, if I take out I as a common factor, what am I left with? If I take out I here, I'm left with minus x plus y equals 2, that is 5 plus I. Right, so now it's clear, this part here, that's real on the left hand side. Can you see that? On the right hand side, this is your real part. So what do we do? Once it's in standard form, we equate real on the left must equal to real on the right. So what is real on the left? Real on the left is x plus y equal to real on the right, which is 5. And now we're going to equate here imaginary on the left must equal to imaginary on the right. So we don't have to copy down the I. We can equate the coefficient of I on the left must equal to the coefficient of I on the right. So what is the coefficient of I on the left hand side? It's whatever's multiplied by I here, so it is minus x plus y, and then on the right hand side, it's just y. So what do we have? Simultaneous equations. Alright, so now it's up to you how you're going to work this out. But for the sake of next week's test, which we are doing determinants, you're going to be tested. Let me just revise determinants here quickly. But in the test or the exam, it's up to you now how you're going to work this out if you have simultaneous equations. You can use substitution, elimination, it's up to you. Alright, let me use determinants quickly. So I've got x plus y is equal to 5, minus x plus y is equal to 1. So I'm going to work out dx here quickly, and then dy. This can be done very fast. So this is the determinant of coefficients. What are the coefficients of x and y? So that is 1, minus 1, 1 and 1. Then for dx, I'm going to go back to the determinant of coefficients, and then I will replace the x column with 5 and 1. For dy, I will go back to the determinant of coefficients, and this time replace the y column with 5 and 1. Right, here the original y column will remain the same, and here the original x column will remain the same. Right, so let's just do this. Now we're going to evaluate a 2 by 2 determinant. You start from the top left, and then you multiply it going down. So that will be 1 times 1 minus 1 times 1. So that will be a 1 plus 1, which is 2 there. Evaluate this one, that will be 5 times 1 minus 1 times 1. So that will just be 5 minus 1, which is 4. We evaluate dy. So that will be 1 times 1 minus 1 times 5. So that will be 1 plus 5, which is 6. Alright, simple procedure. So therefore, x is going to equal to dx over d. What is my dx here? That's 4. And my d is? Your d here is 2. So 4 over 2, that will be 2. And y is equal to dy over d. Your dy is 6 and your d is 2, so that will be. You got that?
Yes.
Okay. So now, let me just go back to this previous step here. So I'm going back to this point here after we simplified. Okay. So that's x plus yi is equal to 5 plus I divided by 1 minus I. So here I had already simplified I to the power 5. Now the other technique is rationalize your denominator, multiply by the conjugate. So what will I multiply by? I'll multiply 1 minus I by 1 plus I and the top by 1 plus I. It's a simple procedure. So let's multiply. So here 5 times 1 that will be 5, 5 times I that will be 5I, I times 1 that is I, and then I times I is I squared. Here the bottom is always the difference of two squares. There's no need to multiply it out the long way. So that will be 1 times 1, which is 1 minus I squared. A squared minus B squared. So here on the top we got 5 plus 5I plus I, which is 6I, and then I squared here is minus 1. Clear with that? In the bottom you got 1 minus I squared, here is minus 1. Right, so now, so therefore we got x plus yi is equal to, on the top we got 5 minus 1 here, which is 4 plus 6i. In the bottom you got 1 minus and minus, that's plus 1 plus 1, that's 2. So now we can divide because there's a constant there. Can you see that? So now this can be written as 4 over 2 plus 6 over 2i. So 4 over 2 is 2 and 6 over 2 is 3. So look at your left hand side. There's nothing to do on the left hand side. Can you see that? So now you've got a complex number on the left and on the right. So what is real on the left hand side? X equal to what's real on the right hand side? 2, and imaginary on the left, or the coefficient of I on the left is y, the coefficient of I on the right is 3. So that's just two different techniques there. Can you see that? So here you are avoiding simultaneous equations, but you have to rationalize the denominator. Right, so that was the first one. Pause there. Right, so here you can see that the right hand side does not need to be interfered with. It's just the left hand side. So now we have two options here. One is just to square it, and the other one will be you can. This is a power, so you can convert this to polar form first, but it's unnecessary. Okay. Let's square it on the left hand side. So here we got 1 minus 2i all squared. Okay. So remember that 1 minus 2i all squared means 1 minus 2i times 1 minus 2i. So if I square this in one step, remember if I have a minus b all squared, this can equal to a squared minus 2ab plus b squared. Okay, that's exactly what I'm going to do now. So if I square this here, that's going to be 1 squared, which is 1. Now the middle term will be 2 times 1 times minus 2i, which is going to give me minus 4i. And the last term will be minus 2i all squared. So that will become plus 4i squared. Alright. On the right hand side it's equal to x plus yi. Simple one to do, you can see that. So here we got 1 minus 4i on the left hand side plus 4 times I squared minus 1. That's equal to x plus yi. So here we got 1 minus 4i, positive times a negative, that will be a minus 4 equals to x plus yi. So now I got 1 minus 4 there, which is minus 3 minus 4i equals to x plus yi. Now it's simplified. You can see you got a single complex number on the left hand side, one on the right. So we equate. We're going to do the same thing. Real on the left equals to real on the right. So real on the left hand side is minus 3, and on the right hand side x, and the imaginary, the coefficient of I on the left is minus 4, and on the right is y. And so basically x is equal to minus 3, y is equal to minus 4. You can see it would be unnecessary to go and convert to polar form and then use the exponent law or De Moivre's theorem. Maybe if this was 1 minus 2i to the power 20, then you are not going to go and do 20 multiples of 1 minus 2i. How long will that take? 1 minus 2i, 1 minus 2i, 1 minus 2i, 20 times. You got no time for that. That's when you use the exponent clause then. Right. Okay, so here we do not need to interfere with the right hand side. Can you see that? It's just the left hand side that needs a lot of simplification. So we got two options here. One is finding an LCD. Okay. The other one will be to divide. You know how to divide in rectangular form. You can rationalize the denominator here, divide this, divide that. Which option would you think is better when you first look at it? LCD. Now, from experience, look, I've done this many times, and the LCD will take a bit longer. Right, there's too much of multiplication involved there. So the best option here will be rationalize each one, divide each one. Okay, so let's do that option first. We can always do the LCD. Alright, so let's see what is going to happen here. I got my 3 minus 2j divided by 1 minus j. I need to multiply by the conjugate in the bottom and the top. Then I got minus 1 minus 3j here. 1 plus j times 3 is the same as 3 times j. I'll have to multiply by the conjugate there too. Okay. The right hand side, you leave it as it is. So, what will I multiply this by? This will be 1 plus j, 1 plus j. What will I multiply this one by? This will be 1 minus 3j, 1 minus 3j. So we're going with this option. Okay. So now, let's multiply out the top and then the bottom here for each one. So here, 3 times 1, that will be 3, plus 3 times j, that will be 3j, minus 2j times 1 is minus 2j, minus 2j times j will be minus 2j squared. Okay, the denominator is the difference of two squares, so that will be 1 minus j squared. You're clear with that? Nothing too difficult here. It's just a lot of multiplication. So now here you got the minus 1 minus 3j times 1 minus 3j is the same as 1 minus 3j all squared. You understand that? So if you know that, then you can do it one step. So that will be, if I square this, that will be 1 minus 6j plus 9j squared. Can you see that? In the bottom, it's a difference of two squares, so that will be 1. It will always be a negative. 3 times 3 is 9, and j times j is j squared. You're clear with that? Which is equal to m plus jp there. Alright, so now here I got 3j minus 2j is just 1j minus 2, and j squared here is minus 1. In the bottom, j squared again, minus 1. Here, I got 1 minus 6j plus 9 times j squared, which is minus 1 there. In the bottom, 1 minus 9 times j squared, which is minus 1. Okay, so here we can add these two real numbers. So you got a minus times a minus, which is a plus there. So it will be 3 plus 2 there, which is 5 plus j on the top. And in the bottom you got 1, minus and minus will give you a plus. 1 plus 1, which is 2 there. Minus here, we got a positive times a negative there. So that becomes 1 minus 9 here. You can see that, which is minus 8 minus 6j. And then you got minus times minus, which is a plus. 1 plus 9 is 10. Is equal to m plus jp. Okay, you need to be careful at this stage here. Okay, there's your division sign, there's the minus there. Okay, so now what can I do here? You can simplify. The reason why we multiplied by the conjugate is so we can divide. Okay, so here, so I can write it as 5 over 2 plus 1 over 2j there. Okay, here. Now notice I'm using brackets. Why am I using brackets? Because of the negative sign here. Can you see the negative sign? So now, this is minus 8 over 10 minus 6 over 10 j. You're clear with that? Is equal to m plus jp. So now let me just remove these brackets. So that is 5 over 2 plus 1 over 2j, negative times negative, that will be plus 8 over 10, which can be simplified further. 8 over 10 will be the same as 4 over 5. So that will be plus 4 over 5. 6 over 10, negative times negative here, that will be a positive. You can see 6 divided by 2 is 3, 10 divided by 2 is 5. So that is plus 3 over 5. J is equal to m plus jp. So now it's just a simple addition on the left hand side. Can you see that? So what are we going to add here? We are adding these two. So we got 5 over 2 plus 4 over 5 here. Here I can add these two also. I can take out j as a common factor. So I'm left with 1 over 2 plus 3 over 5. You're clear with that? Is equal to m plus jp. So here, I'm just going to find an LCD there. My LCD here will be 10. You're clear with that? So this will be 25 plus 8 all over 10. Here I'm going to find an LCD again. So I'm just doing it individually. So that will be 5 plus 6 all over 10. Right, so here 25 plus 8, that is 33 over 10. And here 5 plus 6, that is 11 over 10 is equal to m plus jp. So it's simplified on the left hand side. Can you see that? So now, it always comes down to a complex number on the left and on the right. So real on the left hand side must equal to real on the right hand side. Alright, so therefore, real on the left hand side is 33 over 10 is equal to, what's real on the right hand side? M. And imaginary on the left, the coefficient of j on the left is 11 over 10 equals to the coefficient of j on the right is e. So now, those of you who did the LCD technique, I'm sure the LCD technique involved a lot of multiplication there, more than what we're doing here. Okay, so but it's up to you. There's always more than one way to solve a problem. Okay, you do what you're comfortable with. Right, and the main thing is, don't make any silly mistakes. So a point of interest is this part here, where you have to introduce brackets here. Can you see that? If you do not introduce brackets here, then your signs will be off. Okay, so be careful with that. Do we have time for the last one? Yes, I think we got a few minutes here. Minutes. Let's work out this one here. Application of complex numbers involving determinants here. You can see that? So here, we got a 2 by 2 determinant on both sides. We know how to evaluate a 2 by 2 determinant. Okay, so the left hand side. Your left hand side there, I will multiply going down. So that will be xj times minus 2, which is going to be minus 2xj. You're clear with that?
Yes.
I'll put a minus sign down and I'll multiply it going up. So that will be minus 3 times yj, which is minus 3yj. Simple evaluating a 2 by 2 determinant. On the right hand side, I'm going to go down. Be careful. Okay, this is x minus y. Alright, I didn't write it out properly. It's x minus y, and this is a 2. So if I multiply, that's going to be x minus y times 2. Put down a minus sign and then multiply going up. So that will be minus 4 times j. Now it's much easier than anything we've done before. Can you see that? Just simplify the left hand side. Let's see what happens here. So I got minus 2xj, negative times negative here, positive 3yj. On the right hand side, 2 times x is 2x, 2 times minus y is minus 2y. Negative times negative is a positive 4j. Okay, now let's start equating. Okay, the problem is I have 2 j's here on the left. I need only a single j on the left, single j on the right. You're clear with that? So, what's real on the left hand side? What's real there? 0. Nothing. There's nothing here, so it's a 0. If I take out now j as a common factor, I'm left with minus 2x plus 3y. You're clear with that? Here, this is just 2x minus 2y plus 4j. Now, it always comes down to this here. Real on the left hand side must equal to real on the right. So real on the left is 0. Real on the right is 2x minus 2y. And the coefficient of j, unreal on the left is minus 2x plus 3y. And on the right hand side is 4. So what do we have? Simultaneous equations again. You don't need me to show you how this is simple. Basic simultaneous equations, it's up to you whether you're using substitution, elimination or practice, because you are writing a test next week Monday for maths. And we continue next time.